Multimodal generative artificial intelligence in healthcare is considered the holy grail of artificial intelligence in healthcare. Google just came out with something. Let's find out. The paper that was released by Google is called Towards Generalist BioMedical AI. This is towards. So clearly we're not going to make any judgment in terms of where they are right now. But what we are trying to do over here is to understand where the vision is for generative AI and artificial intelligence, specifically when you have a generalist approach. What they have done, without a doubt, is truly amazing. Let's go to their website announcement. Multimodal Medical AI. This blog post is going to be linked below when you are trying to find it. What they have done is that they have trying to understand that there is a spectrum of approaches in which you can actually create generalist AI. There are multiple tools that you can use. One of the things is that you can use a tool that is smaller artificial intelligence like chest x-ray and mammograms, and then you can use model grafting to go towards generalist systems by combining different artificial intelligences. And we're going to talk about this more. What they have shown is that you can combine different artificial intelligence techniques like computer vision, which is the image encoder over here, and a large language model, which is medical information, combined into a large language model, so you can get results that are more contextual based on a patient information and also using both tools simultaneously. I'll show you some examples in the video. And of course, this is the real goal that we are trying to do. You can have a chest x-ray, a dermatology, a mammogram, clinical notes and reports, genomics, lab tests, pathology, other question and answers combined into one generalist model. And that's what Google's trying to achieve. That's, to be honest with you, I'm personally working on. And the idea is where this process is going to move forward, because this is a big thing that not one company can do, but multiple small companies are going to do together. How? We have talked about this before. Artificial intelligence as a service. There will be multiple people building different modules. I'm building intracerebral hemorrhage, somebody's building CT perfusion, other one's building CTA chest. All of these small modules are going to combine. And then somebody else is building ischemic stroke, somebody is building a chest x-ray, somebody is building mammograph. These are all computer vision. There's a whole slew of companies that are working on digital pathology. There's another slew of companies that are working on EHR summarizations. There are other companies that are working on back clinical stuff like improving insurance authorizations, payments, etc. All of this. Each and every service is going to combine and then become what we always thought it will be, a generalist artificial intelligence for healthcare. And we have been, you probably have heard me show this screen before as well. And this is now truly possible because we needed two breakthroughs. One was the transformer AI technology, in which anything can be vectorized and therefore understood by computers in the mass they want to understand. Literally, you can vectorize any form of data, and therefore you can transform any data from one place to another. So therefore you can write a text to show image, you can do text to audio, and you can do audio to text, etc. And therefore this is truly the artificial intelligence movement we have been looking on. Artificial intelligence, which is basically the transformer technology, and then most importantly the availability of compute power and the data that has significantly changed the way we do medicine, and of course everything else now. Before I get into this, I wanted to take a minute to show you one of my applications that I've been working really hard to achieve. This is a NeuroChat, but we have been working on for a long time. This is in beta phase. Please make sure you review it, check it, give us some feedback so we can improve it. Let me just try something. I am an angel investor looking for companies in generative artificial intelligence. Can you give me ideas of artificial intelligence in digital health, specifically digital pathology? And I can actually look at, just through brainstorm with the artificial intelligence live, to see what they come up with. And as you can see that they come up with these different ideas of companies. So that's good to know that these are the different ways that people can search. So I know what competition is going to come tomorrow if I'm an angel investor. Can you give me SWOT analysis of the first idea? And not only that, I can go deeper into the second part, and that's how you're going to use large language models, because it's not just about getting the first prompt, but also digging deep with these tools to make sure that you understand much better. Here's the SWOT analysis. You can see large potential market. There's regulatory hurdles, expanding usage analysis. So this is beautiful and quite accurate, to be honest with you. But of course, make sure that you do your due diligence before you copy paste it. But at least it's a great starting point for you to do, rather than going through different tabs on websites, etc. And you can get this information in the palm of your hand. I'm using it on the tablet. It's also going to be available on web. It is definitely available, of course, on mobile. If you want to download it, please pause here. Make sure you scan that QR code. The links are also in the description. Now let's get to this paper in question. What is the biggest thing that they are working about? And that's the term that you have to understand, because you don't have 2 words. Again, this is not something that they're claiming that we have achieved generalist biomedical AI. Nobody has. And if somebody that had it, believe me, their market value will not be 3 trillion, which is Apple and Google. Maybe it is going to be at least $6 to $10 trillion, because the global market for healthcare, especially with generalist biomedical AI, is huge. As a matter of fact, this is going to be a company that goes there first is going to be technically a billion-dollar company, a multi-billion-dollar company for sure, maybe a multi-trillion-dollar company. Now, one of the things about medicine that we have talked about before is it's inherently multimodal. We have imaging, text, genomics, etc. And what they did is MedPalm model is a proof of concept. Of course, this is clearly, as I said, proof of concept model. One of the things that they have tried is before, like so many things that are going into multimodality of a medicine, and therefore you can tailor this significantly. I love this that they have shown mammographic classification. Believe me, these are open source models that are available. Genomics, radiology reports, summarizations are all available. As a matter of fact, medical question and answer is going to be available in NeuroChat as well. The idea behind it is that we are slowly moving towards just not using large language models that are specifically, which again is in itself a regulatory problem, but also we're combining all of these 3s, and the way they have done it is actually good. First what they did was that they curated a multi-benchmark. So if you can't really test it. So first of all, they created this with 14 different tasks. And once they got this particular test done for their future artificial intelligence, then they went back and actually created different models. First, they created the MM, and then the novel emergent capabilities they were able to see, and then they ended up doing human evaluation. One of the emergence of these foundation model paradigms, like what is the foundation model? We have tried this before. Actually, you can see the Claude AI, chatgpt, Palm 2, these are all foundation models. These are fine-tuned models, medquery, synaptic node, etc. And Falcon 40B is a foundation model. However, it is actually open source that we are fine-tuning for ourselves. So when you have the foundation model paradigm in which you are creating a model that is specifically has so much data and information that you can get that foundation model in, and once you have that foundation model, you create fine-tuned models from there. And this foundation model paradigm needs to be turned into multimodality, and that is where the real money comes in, believe it or not. The multi-benchmark for generalist biomedical AI, they did all these tasks, modalities, text, radiology, pathology, dermatology, mammography, and genomics. And of course, they did question and answering, report summarization, visual questions, etc. And then if you can see what the process they went through as far as making. So first they created a PALM, which is just a large language model. Then they created a visual transformer, which is actually exactly that I talked about before in this. When we are talking about transformer technology, the idea behind it is that when you use transformers in artificial intelligence, you can convert one form of data into another, because the baseline vectorization was the key feature in generative AI and what we consider transformer technology. And then once they created not just the large language model, which is of course based on transformers, they were actually creating visual transformers as well. And this way they were able to introduce PALM-E, which is a sequence of multimodal imaging, and then finally they put it all together. Again, remember, artificial intelligence as a service. You put it all small pieces, you take 1, 2, 3, 4, 5 different models. In this particular one, they did the mammogram and the chest x-ray. I'm doing CT hemorrhage and CT ischemia, and then etc. etc. At the end of the day, what everyone is going to build towards is these smaller services they're going to churn into, they're going to build into one large artificial intelligence. And it's been rumored, of course nobody can confirm that, ChatGPT 4 is actually made up of 8 different smaller models as well. Anyways, this vision is superb, and one of the examples that they're giving is also very, very interesting. So I'm going to give you this. You are a helpful radiology assistant, describe the lines and tubes, and then given the lateral view. So that's not really amazing. As a matter of fact, this is a DICOM tag. But anyways, as compared to the previous radiology, there is no relevant change. So not only was it able to see that this is a particular kind of chest x-ray, it is a lateral view. It was able to compare from a previous study and then give you in a video, in a written report, that this is actually the possible relationship or disease or pathology, what again with a comparison of this. No pathological findings in lung parenchyma noted, etc. A faint 2 mm round opacity projections were seen. Same thing. You are a helpful dermatology assistant. So this is the video image they upload, and they say that patient history, 51-year-old female smoker, which is false, drinks false, and then is the lesion, and then over here they can say lesion, ring, region, black, itch, falls, etc. Which of the following is the most likely diagnosis of patient's skin line cancer? And they go to nevus basal cell carcinoma, and they pick up the right answer, A, basal cell carcinoma. This is tremendously going to change the way we do medicine. And this is, again, just a proof of concept. This is just the start. I don't know where we're going to be in 10 years.